Alright, go ahead and get your geobooks out. It's time for video number 11. This video is about triangle types, interior and exterior angles. Okay, go ahead and turn to the next vocabulary word in your geobooks and write the word triangle types. Okay, so your three triangle types that we're going to talk about today are acute triangle, obtuse triangle, and right triangle. Acute triangle means that a triangle has all angles that are less than 90. So if you look over here on this side, we have this triangle with 30 degrees, 80 degrees, and 70 degrees. So notice that they are all less than 90 degrees. Then we have obtuse triangle, which is a triangle that has an angle that is greater than 90. So it's just one angle that is greater than 90. So we have the 20 here, which is less than 90, 50, which is less than 90, and then finally we have our 110, which is greater than 90 degrees. And then finally we have our our right triangle, and that is a triangle with the right angle of 90. So here is our 90 degrees and 56 and 34. So it's just one triangle that has a 90-degree angle in it. Go ahead and stop the video here and write the notes. Okay, your next vocabulary word is interior angles of a triangle. Interior angles of a triangle, just remember that whenever you're talking about the angles that are inside of any triangle, they always add up to 180 degrees. So we have this example over here. The angles that are in this triangle are 70 degrees, 60 degrees, and 50 degrees. And if you go ahead and add them up, 70 plus 60 plus 50 is equal to 180. And then why is this? So think of having that triangle in a sheet of paper, and then you rip out the angles, the three angles from it, and then if you were to put them together like this, notice that it forms a straight angle. And remember that a straight angle, which makes a straight line, is always equal to 180 degrees. So this is a way to remember why the angles inside a triangle always add up to 180 degrees. The other thing you have to keep an eye out for is whenever you have a triangle, you remember that it adds up to 180. The angles add up to 180. And because of this, only one of the angles can be 90 degrees or more. So for example, if you have a triangle that is a right triangle, and we know already that one of the angles is 90 degrees, then it can't have another angle that is more than 90, because since you already have the 90, if you had another 90, then it would be 90 plus 90, which would already be your 180, and you can't have that because you're still missing another angle. So just remember that you can only have one angle that is 90 degrees or more. The other ones would have to be less than 90. Okay, go ahead and stop the video here and write your notes. Okay, so we talked about the interior angles of a triangle, and now we're going to talk about interior angles of any polygon. And right here we have definition of polygon. A polygon is just a figure having three or more straight sides. So it can be a triangle. A triangle is considered a polygon. A square is considered a polygon. Pentagon is a polygon. Octagon, etc., etc., etc. Okay, so we have this example over here. We have a quadrilateral, and a quadrilateral has four sides. Okay, 1, 2, 3, 4. And if you take this quadrilateral and you draw a diagonal line from one point to the other point, we can't draw one from this point to this point because there's already a line there. But from one point across the quadrilateral, you guys can notice that we make two triangles out of this quadrilateral. That means that from the previous slide, we know that one triangle, the sum of the interior angles of one triangle is equal to 180. And then we have another triangle, and the sum of the angles of that triangle are equal to 180. And if we take those two and add them together, then the sum of the interior angles of this quadrilateral would have to equal to 360. And it's the same thing for all the other polygons. If we were to draw a pentagon and draw the triangles that are made from that pentagon, you would know that it makes three triangles. So 180 plus 180 plus 180 is equal to 540. A hexagon, it makes four triangles. And so 180 times 4 is 720. And then so on and so forth. So if you guys can see the pattern, the number of sides, you're always going to subtract 2 and multiply that number by 180. So this is the rule that you would follow to find the sum of the interior angles of any polygon. Go ahead and pause the video here and copy your notes down. Okay, next we have exterior angle. And an exterior angle is an angle that is formed by one side of a polygon and the extension of an adjacent side. So if you look at the picture over here on the right side, we have a triangle here, which again is considered a polygon. And if you extend one of these sides, we create what we call an exterior angle. And an exterior angle is just an angle that is outside of your original polygon. And then the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles of the triangle. And the two, remote interior angles of this triangle are the angles that are the furthest away from your exterior angle. The ones that are not sharing that same vertex as your exterior angle. So it has to be these two, the ones that are across and not sharing the same vertex as your exterior angle. So in this example, our exterior angle is angle 1, and the measurement of angle 1 would be equal to the sum of the measurement of angle 3 and the measurement of angle 4. Okay, go ahead and stop the video and copy down your notes. Okay, turn to the next available notes section of your geobook. We have our first example for today. This example, it says to find the missing angle of the triangle. So they give us this triangle over here. One of the angles is 82, the other angle is 55, and then we're missing this angle. So if you remember from the theorem, the interior angles of a triangle, of any triangle, add up to 180 degrees. So pretty much what you have to do is you're going to take your two angles that are given to you, add them together. So 82 plus 55, and we get 5, 6, 7, 8, 9, 10, 11, 12, 13, 137. And we are going to subtract that number from 180 because we know that they all have to add up to 180. So subtract 137 from 180, and you get 43. So then that means that your missing angle would have to be 43 degrees. And just to double check, if we add 82 plus 55 plus 43, we can see that we get 180 degrees, and that's what we wanted. That was our goal that we wanted to achieve. Okay, so go ahead and write this in your geobook, and we'll go to our next example right now. Okay, in example 2, we have to find the sum of the interior angles of a regular hexagon. So here we have a hexagon. A hexagon has 6 sides, 1, 2, 3, 4, 5, 6. And the same thing that we did on our notes in the vocab section, we have to figure out how many triangles can we make out of these this hexagon right here. So we're going to choose any point, any vertex from our hexagon. So I can choose this one. I could also choose this one or this one or this one or this one or this one. It doesn't really matter which one you choose, but once you choose one, that's the one that you have to stick with. Okay, so if I draw, I can't draw a line from here to here because like I said in the other slide, we already have a line here, so there's no need for us to draw a line from this point to this point. But we could draw a line from this point to this point because there is no line there so far. So we're going to take from that point and extend our line to that vertex. We can also extend one to this vertex, and then finally we can extend it to this vertex. Again, we cannot draw one from here to here because there's already one there. Okay, so if you look at how many triangles we made, we have 1 triangle, 2, 3, and 4. So we would take, remember that each triangle has the sum of 180 degrees for the interior angles. So we're going to take 180 times 4 because we have 4 triangles. And when you do that, you get 700. What happened? 720 degrees. And that would be the sum of the interior angles of this regular hexagon. Another way you can do this, if you want to follow that rule that you guys had in the previous slide, we had n minus 2, and then you multiply that by 180. And then n is just the number of sides. Okay, so a regular hexagon, has 6 sides. So then your n would be 6, and if you would plug it in here, you get 6 minus 2, and 6 minus 2 is 4, and we have to multiply that by 180, which is pretty much what we did over here on the top, and you get the same answer of 720 degrees. So you can do this either way and you get the same answer. Okay, go ahead and pause the video here and copy this down. Okay, and this is our last example for this video. And this example is asking us to solve for x. And if you look at this picture, you guys can see that we extended one of the lines of this triangle. One of the sides of this triangle, and we created an exterior angle. And remember that the rule for exterior angle is that angle, your exterior angle, is equal to the sum of your 2 remote interior angles. So again, remote interior angles are the angles that are the furthest away from your exterior angle. And another way to remember this is the angles that do not share that same vertex. So this angle would not be one of your remote interior angles. It would have to be these 2. Okay, so we know that the rule says exterior let me just write this down. Exterior angle is equal to remote angle plus the other remote angle. Okay, so our exterior angle is equal to 100. So we're going to write that right there. One of the remote angles is equal to 3x. And the other remote angle is equal to 2x. Okay, so we're going to drop the 100. 3x plus 2x is equal to 5x. And we divide by 5 on each side. And when we divide by 5 on each side, we get that x is equal to 20. And that is our final answer. Go ahead and pause the video and take the notes down.
We don't talk anymore. We don't talk anymore. We don't talk anymore like we used to do. We don't laugh anymore. What was all of it for?